So there is an undirected graph with n nodes, which each node 0 to n given 2D array, where this graph U is an array of nodes that node U is adjacent to. Okay, given a 2D array graph where graph U, okay, graph ith row, if ith row is array of the nodes that U is adjacent to. So more formally, that for each V in graph U there is an undirected edge between U and V. The graph has following properties: there is no self edges, does not contain U, okay, there is no loop, okay, parallel is not there, okay, V is in the graph. If V is in the graph, then U is in graph V, the graph is undirected, okay, means UV, graph UV is equal to graph VU is equal to 1. The graph may not be connected. The graph may not be connected, meaning that there may be two nodes such that there is no path between them, okay, that means different island type. So a graph is bipartite if the nodes can be partitioned into adjacent sets A and B such that every edge in the graph is connects to a nodes in set A and node in set B, okay, return true if and only if it is bipartite. So for every DF, let's run a BFS, and it is a two coloring problem, right? So let's mark it as blue. So if it is blue, then the neighboring nodes must be marked as red. So so if it is not visited, okay, so there is no point of visiting, so 0. So it is an integer, 0 and 1s, so 0 and 1s, okay, it should be 0 and 1 or what? No, okay, we have to construct the graph. So 0 to n minus 1, so 0, okay, so graph is 1 to 3, that means 0 is connected to 1, 0 connected to 2, 2, 3, 1 is connected to 0 and 2. Okay, let's create the edge and then think. So question number 10 is bipartite, so boolean is bipartite. Bipartite with the vector of graph. So okay, vector of integers, graph. Okay, so that means graph of size, give me 0, 1, 2, 3, 4 nodes are there, so let's go to, it's required actually, anyways. So for every node I can traverse and get the, yeah, I'm given the adjacency list only, so why to care about creating the graph again? Is bipartite, you've given the graph, at least we know the number of nodes. Graph dot size, so let's run in the at least one node, graphs not length, and is at least one, so at least one node is here. So let's mark the color of every node. So we will have a vector of integer color, every node is uncolored. Let's mark the color of 0 node as 1. We'll mark every node as 0 or 1. Okay, so let's start with 0 only. So color of 0 is 0. Every adjacent nodes of 0 should be marked as 1. Then every adjacent nodes of 1 should be marked as 0. So I think BFS should work. So let's create a queue. So queue dot push the node number 0, and so while my queue is not empty, my queue is not empty, queue is queue dot front and queue dot pop. So let's traverse over all the nodes of this node, of all the adjacent nodes of u. So if I know the color of, so that means every node I pop, I already know the color of that, right? So u, before pushing I need to mark it. So two things. So if adjacent node of u, we need to find adjacent nodes of u. So from u to v there is an edge. Then v, if v is not colored, okay, so if v is not colored, so if color of v is equal to -1, but what about there may be connected components, many connected components. I think this should be run inside a loop. Okay, let's see. So while queue is not empty, okay, pick the first element and go to its neighbor. If it is not colored, fine, color it with the opposite color of u, else that means it is colored. So if u is colored with 0 and I came across v, okay, so v is colored with 1, then I am fine. But if v is also colored with 0 by some other node, so if color of v is equal to color of u, that means return false. We can return, otherwise return true. But how to handle distinct components? Can we do DFS? Okay, so what happened here? So go to, okay, and is graph size vector color array. Every node is colored with, is not colored, mark 0 as 0 and go from here. And so while queue is not empty, pop that node, go to its neighbor. So if neighbor is not colored, color that neighbor and push it in the queue. So queue dot push that node in the queue, okay, with a different color. But if that is colored with the same color as u, and that means they are not bipartite, right? Graph is not bipartite. But how to handle the different? I think it will be same. So go to all the nodes for int I less than n. Go to all the nodes. If it is not colored, say color of this is -1, that means color it with 0 and push it inside the queue and perform the rest of operations. Perform the rest of operations. Then so while queue is not empty, so push the I, and while queue is not empty, go to the locations, mark it as okay, it's messed up. So while queue is not empty, remove from the front, and so go to all the neighbors. If neighbor is not colored, color it, push it to the queue, else okay, if the for loop is here, while loop ends here. So if blocks return comes here and it is here, okay, I think this should work or not. Let's see. Okay, is bipartite. Nice. So is graph.size, color, everything is -1. Go through this, and if it is if it is not colored, color it with 0, push it in the queue and run a BFS from here. Queue is not empty, queue.front, queue.pop, go to the neighbor. If neighbor is not colored, go to the neighbor. So if neighbor is not colored, mark it with a different color, so 1 minus color of u, and push that neighbor. If neighbor is colored with a different color already, then fine. Otherwise if it is colored with the same color, that means there is an edge. So if we try to keep them in different, so there will always be, so they have the same color, that means there will always be an edge. They cannot be divided into two different sets. Okay, fine. So if none of the what is this, it should work. What? Now it is showing. So let's have a queue of the queue, mark it colored, and color push it inside the queue and run a BFS from here. it is working. It should work for other cases also. Yeah, first attempt. Thanks.